We're going to learn about something called standard deviation, which is a statistic that we use a lot in our class. We use it with quantitative data, so it's specific to quantitative data, things that you can measure with a ruler or a scale, and it always is paired up with the average or the mean. We're going to first learn how to calculate it, and then we'll talk a little bit more about what it means and why it's useful for us. So, we're going to suppose that we draw the following information from a population of things. Let's assume, just for our example right here, that this is the number of minutes it takes you to get to school. So we have an entire school full of people, but we survey 7 of them. So n equals 7. And this is what we get. We want to calculate the mean. Now remember, the mean is the average, and we said that this is a y-bar, so the average would be 14 plus 13 plus 20 plus 22 plus 18 plus 19 plus 13, all divided by 7. And this comes out to be 17, so in this case average 17 minutes. Now we take this and we use it in our calculations. We list all the original points again, 14, etc., all of them here, and then we find something called a deviation. A deviation is the distance away from the mean. So a distance away from y bar. So for example, 14 minus the mean gives us -3. 13 minus 17, -4. 20 minus 17. All of these are distance of this point and the mean. 3, and so on. So this gets 5, 1, 2, and this one is going to be another negative in here, a -4. Now, if we were to take and to sum all these up, we would end up getting a 0. This will always happen. Every time you calculate the deviations and you add them, you get a 0. That wouldn't be too bad, except one of the things we want to do with these deviations is we actually want the average. We want the average deviation, and if I'm going to add all these up and then divide by 7, it's going to be 0 always, and that's not a very helpful average for us. So the reason that we're getting 0, if you think about it, is because we have some of these negatives in here, and these negatives are canceling with the positive numbers. That's why we get 0. So in order to get rid of the negatives, we're going to square all of these deviations, and if we can square all of them, we'll get 9, 16, 9, 25, 1, 4, 16. Now if we're going to sum them up, we will get 80. This number we could divide by 7 and we could get an average deviation or an average distance away. So adding up the square deviations, that's our 80. We then take this number and we divide it by n minus 1. In our case, we had 7 data points minus 1. So 80 divided by 6, which gives you 13.3, repeating. So far, we're doing good. We're getting an average number here. But remember that average, we squared them. And so to undo the squaring that we did, we're going to take the square root. So we're going to take the square root of 13.3 repeating, which gives us 3.65. And this is still minutes for our example here that we're talking about. So this is a standard deviation. You find your mean, you subtract every single point from that mean, square all those numbers, and then you divide them by 1 less than the total number of things, and then undo the squaring with a square root. And you're going, okay, not too bad, but what does this actually mean? Well, to help with this, let's draw a graph. So let's think about drawing a graph of all the data points in our original set here. So we had a data point at 14. We had a data point at 13. We had a data point at 20. Data point at 22. At 18. At 19. And another one at 13 in here. So this is the people and the number of minutes it took them to get to school. Interestingly enough, our average was at 17 right here, right? This was our y bar. And there wasn't actually anyone who fell at the average, but we know that that's where this would balance, right? If you think about this being like a seesaw, and here's where the seesaw is trying to balance, this is where it would even out. So that's our mean. The deviations, so a deviation is the distance a given point is away from the mean. So the deviation of this point is 1 unit. He's 1 unit away. The deviation of this point is 2 units. This one is 3 units away. This one is 4 units away. This one is 3 units away. This one is 4 units away, and this one's another 4 units away. So each one of those lines is a deviation. A standard deviation is the average distance. The average distance of all points away from the mean. So if you were to think about, okay, these are all my things. This one's pretty close. This one's kind of far away. These ones are kind of in the middle. Yeah, you're kind of in the middle. What's the average distance away? That's what this number is. This tells you the average distance of all points. So 3 and about half, right? It's 3.6, but let's say it's like 3.5 units. 17 plus 3.5 would give us 20.5. So right in here. So this is 1 standard deviation away. And then we have to go the other direction too. So 17 minus 3.5 puts us at like 13.5. So it's telling us most of our points, here's the average, but most of our points fall about this far away. Now this one's really nice, right? You can see that they fall pretty close to him. This one, it's a little more spread out. This one's kind of far away, and this one's kind of far away, and these ones are a little close. That's how it happens. Sometimes they fall close, sometimes they're a little spread out. But it just gives us an idea of, do I have a really stretched out graph, or are all my points pretty close to my mean? So this is a standard deviation. It's the average distance of all points away from the mean.